Hello and welcome back to my channel once again. This is your man Alam, and today's tutorial we start be looking at the integrating factor method that's involving constant coefficient in solving ordinary differential equations. In my previous video we have looked at other methods that we can use to solve ordinary differential equations. Now this is a question given to us to prove. It says that given the constant a, b, which belongs to all real numbers, with a not being equal to 0 and b not also be what equal to 0, the general differential equations of the form y prime equal to ay plus b. Now we should prove that the solution is given by y equal to c e exponent at minus b over a. Like I said in the previous video, we have looked at how to prove this particular formula using other methods. So in this particular tutorial, we shall be looking at the integrating factor method into solving this. And then after we have done proving it, we shall take some examples and then we explain it better for our understanding. So without much ado, let's dive into the video and carry on. So solution, we have y prime to be equal to a y plus b. We group all the y's to the left hand side or to the right hand side, so but I would put them at the left hand side. So we have y prime minus ay equal to b. Now we multiply through by an integrating factor, say u. So if I multiply this by y prime minus multiply this by 2 by u, then this by u. Now let the negative u to be equal to u prime. If that's the case, we replace it into the previous one. So I have u y prime plus u prime y to be equal to bu. Now we have y prime and then u prime. So I can factorize the whole thing as u y all prime. So when I differentiate u with respect to y, then I'll have y prime. That's y, differential of y will be y prime using the quotient rule, so the product rule. So y prime plus, then you differentiate the u by holding y, then you have back the previous equation, and this is equal to bu. So I can say this is my equation 2. Now from equation 1 we can find u and substitute it inside equation 2. So from equation 1, I have my u to be equal to that is differentiating this, that's u prime over u will be equal to negative a. Rewrite it. So I have u absolute prime to be equal to negative a. I'm taking the limb of this so that when you differentiate the limb of u, you have u prime over u. Okay, then take the integral on both sides. It's equal to respect to t. Then integral of this will give me lim u, and this is equal to negative a t plus a particular constant c. Now take e on both sides, so e exponent u to be equal to e exponent at plus c, and this means that I'll have u to be equal to c e exponent at, where c is equal to 1, implying that u will be equal to e exponent at. Now I can substitute the u inside equation 2. So wherever I see u, I substitute inside. So I now have e exponent this y all prime to be equal to b e exponent negative 80, which is further equal to, so I have e exponent negative 80 y all prime, which is equal to b e exponent a t e a t y prime is equal to, I differentiate e exponent negative 80 respect to the b. The b is a constant, so it still maintains. So I have this, so that I'll put it like this. So we integrate it and then we differentiate. Now when I differentiate it, it means I'm getting back this. It doesn't make any difference. So we just integrate it and then we have put a differential sign there, which is now implying that when I bring it to the left hand side, I'll have, so remember this is, sorry, this is minus is here. So when I'm bringing it, I'll be positive over a e t all prime, and this is now equal to 0 because I'm picking everything across. I can factorize everything inside the bracket, that b over a e exponent 80 all prime is equal to 0. Now let what is inside the bracket is what we call the potential function, which is equal to e a t y plus b over a e exponent 80, which implying that this prime is equal to what? 0. Now I take integral on both sides. Is equal to integral of 0 respect to t, implying that I'll have this to be equal to c. But I know that, implying that my e exponent a t y plus b over a e to the t is equal to c. I'm looking for y, so I maintain y at the left hand side. So I have e exponent aty equal to c. Picking this across will be minus b over a e to the 80. Now divide through by e to the a t, and divide here by e to the negative 80 divided by e to the negative 80, and this goes with that, leaving y to be equal to c e exponent 80. The negative here turns out to become positive, so therefore I write it as e to the positive 80 minus this cancels that, leaving b over a, and that we have proved what they are asking us to prove. All right, so with that you have been able to prove that y prime equal to ay plus b is equal to y equal to c e exponent 80 minus b over a, and then you are good to go. Now I want to pick some 1 or 2 examples, then we prove it correct. Now example 1, solution. It has been given that we use y prime equal to 2 y plus 3. So I will have y prime group like terms, so I have this equal to 3 multiplied by an integrating factor u. So y prime minus 2uy is equal to 3u. Now let u prime to be equal to negative 2u, and maybe this is equation 1. Now we can substitute the equation 1 back into the previous equation. So I have u y prime plus, when you are putting inside, so we are picking the negative 2u, so here becomes a positive. So I now have u prime y to be equal to 3u. I can factorize it, so I have all this prime is equal to 3u, such that when I differentiate the uy using the product rule, I'll get u, holding u, differentiate y, get y prime, plus you hold the y, then differentiate u, you get u prime. So you have just gotten what you are looking for. So say that is equation 2. Now from equation 1, I can have u prime over u to be equal to negative 2. And from this, I can have the limit of u all prime to be equal to negative 2. Take integral on both sides. And that is going to give me lim of u to be equal to 2t plus c. Now we are looking for the u, so I take the e on this equal to e negative 2t plus c. So it means that u is equal to c exponent negative 2t, but c is equal to 1. Okay, implying that my u will be equal to e exponent negative 2t. Now we substitute this inside equation 2. So from equation 2, I have e exponent negative 2t y all prime to be equal to 3u, which is negative 2 e to the power negative 2t. Now this can further be written as 2t y all prime is equal to, integrate what is here. So if you're integrating, you differentiate the e exponent negative 2t and divide it with it. So I have negative 2 over that, negative 3 over 2. So that's the integral of it, and you differentiate it. So it means you have to integrate and differentiate to get back this original one. So you have not changed anything on it. Now, after you have done this, you group like terms. So I now have e to the negative 2t y all prime plus, it was negative, coming to the left hand side will become positive. So I now have 3 over 2 e to the negative 2t all prime equal to 0. Factorize everything inside the bracket. I have y plus 3 over 2 e t all prime is equal to 0. So the potential function, this becomes the potential function. So now let this to be equal to e exponent 2t y plus 3 over 2 e that, implying that this prime will be equal to 0. Now take integral on both sides, which means that my u, that's q, will be equal to c, implying e, but we know that q is equal to that, so e exponent negative 2t y plus 3 over 2e negative 2t is equal to c. I'm looking for y, so I maintain the y and then we pick the other coordinate, the next side. So we divide through by e to the power negative 2t, so I have e exponent 2t y divided by e to the 2t is equal to c dividing e to the negative 2t minus 3 over 2 e to the 2t divided by e to the negative 2t, and this is going to cancel, leaving y to be equal to c over e to the negative 2t minus 3 over 2, because this is also going to cancel this, and this can be rewritten as c e to the power 2t minus 3 over 2, and this is the solution to the differential equation we have solved. The next example is that y prime equal negative 3y plus 1, where y of 0 is equal to 1. So this, when they give you the value of t and y, we call it the initial value problem. So they have given us an initial value problem, and then you use the integrating factor method to solve it. So therefore, I group like terms like we have been doing. So this is negative 3t, coming here will be positive, and this is equal to 1. Multiplying by the integrating factor u, so I have 3u y to be equal to u, okay, and then let 3u to be equal to u prime. So say this is equation 1, implying that my u y prime plus u prime y will be equal to u. Factorize it, I have u y all prime equal to u. So this is my equation 2. But from equation 1, I have y u prime over u to be equal to 3. Taking lim on it, so I have lim u prime to be equal to 3. So you take the integral on both sides, and this is with respect to t, okay? So I now have lim of u, so the prime go with the integral sign and leaving only lim u to be equal to 3t, okay? Now plus a certain constant. When you're integrating, there's always a certain constant that will add it, but in this our case, this one will always be equal to 1, okay? So take the e on both sides, e exponent 3t plus c. So it means that my u will be equal to c3 exponent that, where c is equal to 1, implying that u is equal to e exponent 3t, okay? Now whenever you see u in equation 2, you substitute e exponent 3t. So substituting u into equation 2, I have e exponent 3ty all prime is equal to e exponent 3t, okay? Now we integrate the right hand side and differentiate it. So I now have 3ty all prime is equal to e exponent that. When you integrate, you get this and now we differentiate so they can get back the original equation. Now e exponent 3t y all prime, and bringing the other one which was positive, I now have this, and this will be equal to what? 0. Factorizing everything into one bracket, I have this all prime, and this is the potential function. So we let mu to be equal to e exponent 3t y 1 over 3 e exponent 3t, okay, and which implies that this prime will be equal to what? 0. Okay, let's integrate both sides of it respect to t, imply that this will be equal to c. Now, but from the previous one, we have e exponent 3t y minus 1 over 3 e 3t to be equal to c. Make y the subject, so we have this. We send the other to the right hand side, which was negative in this side, so coming here will be positive. Okay, divide through by e to the power 3t is equal to e to the power 3t plus 1 over 3 e to the power 3t, and this cancels that. This also goes with that. My y will be equal to c. Rewriting this will give me negative 3t plus 1 over 3, and this is the one that is what required. Right, thank you for watching. Don't forget to hit the subscription button and the notification button so you'll not be left out when I release any other new video.